Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Given a 4x4 matrix A, we want the elimination matrices E21, E32, and E43. Each one is designed to zero out a specific entry below a pivot using a row operation encoded as a matrix. Elimination is just a row operation. Subtract a multiple of the pivot row j from row I so that entry ij becomes 0. The elimination matrix is the identity matrix except for one key entry. At position ij, we place minus lij. Multiplying eija performs that row operation automatically. First, E21 would eliminate the entry in row 2, column 1, using the pivot at row 1, column 1. But the entry is already 0, so the multiplier is 0, no elimination is needed. Therefore, E21 is just the identity matrix. Next, we eliminate the entry in row 3, column 2, using the pivot at row 2, column 2. The multiplier is 1, meaning row 3 will subtract exactly one copy of row 2. This is the elimination step. Row 3 becomes row 3 minus row 2. Translating that row operation into a matrix means we place minus 1 in the 3-2 position of the identity. This matrix performs row 3 minus row 2 when it multiplies A on the left. Notice something special. Rows 2 and 3 are identical in the original matrix. So when we subtract row 2 from row 3 becomes the 0 row. That means the would-be next pivot at position 3-3 becomes 0. Now we want E43 to eliminate the entry in row 4, column 3 using the pivot in row 3, column 3, but that pivot is now 0. The elimination multiplier would require dividing by 0, which is impossible. So elimination breaks here. Without swapping rows or columns, we cannot form an elimination matrix that uses a 0 pivot. First elimination was unnecessary since a 2-1 equals 0, so E21 is the identity. Second elimination uses multiplier 1, so we place minus 1 in position 3-2. The key insight is that elimination can create a 0 pivot, especially when two rows are identical, so the next elimination step can become impossible unless we introduce a row exchange. Watch the next video to see how a row exchange, a permutation step, fixes the 0 pivot problem and lets elimination continue smoothly.